Welcome to this revision blast for AQA GCSE Geography. Today we are focusing on river landscapes, which is part of the physical landscapes of the UK unit, which you will find on paper 1. We're going to kick off proceedings with a round of altered vowels, where each of the key phrases or key terms shown have had the vowels changed to an alternative. You just need to work them out. So our first one is on the screen already. So have a look at this word. The vowels have been changed. The consonants are the same. What key term are we looking for here? Okay, let's reveal. It is tributary. So a tributary is a small stream feeding into the main river channel. Right, a slightly trickier one here. Just going to give you a moment to try and work this one out. Let's have a look. It is drainage basin, also known as a catchment area, and the drainage basin is the area of land that is drained by one river and its tributaries. Number 3. So this is a tricky term. This is a term that students often forget. It's a term that, for whatever reason, seems to be harder to learn than the others. And also the altered vowels has made it look even more difficult today. So let's have a look at what it is. It is a confluence, and the confluence is where two or more rivers join together. So let's move on to a slightly easier one. So we've got the extremes of a river here. Hopefully you've been able to see this one straight away. This is source and mouth. So the source is where the river starts its journey, so it tends to be up in highland. It's not normally very, very small. The mouth is where it reaches the sea. And then we have number 5. So this one is not tricky in terms of being able to recognise what the word is, but again, it's one of those key terms that we often forget. Let's have a look at what it is. It is the watershed. It's the area of highland that separates two drainage basins. Right, we're going to move straight on to a 60-second challenge. We are still looking at key terms or key phrases. This time you've got 60 seconds to match the key phrase to the definition. So matching the letters on the left with the numbers on the right. And if you don't have a pen and paper with you, you might want to pause and get one for this activity. So let's start our time now. Okay, hopefully you managed to match all 5 key terms and definitions up. Let's have a look at the correct answers. So we have A for erosion, which is the wearing away of the river bank or bed by flow of the water. We've then got underneath it the different types of erosion. So when you're talking about key processes and how landforms are created, you need to be able to talk about specific processes of erosion. So let's have a look at what they are. We've got B3, which is hydraulic action. This is the force of the water hitting the riverbank and squeezing air into the cracks in the rocks and weakening them from the inside. We've got abrasion, which is the force of sediment and rocks in the water scratching and scraping away at the riverbank and bed. So that was C2. D1 is attrition. This is a process of rocks hitting each other and breaking into smaller rocks as they're being transported along. And E5 is solution. This is a chemical reaction between the river water and the minerals in the rocks in the riverbank or bed, which causes the rocks to dissolve. So well done if you got all of those correct. Right, we're now going to play something called Don't Draw the Short Straw. You're about to see a question with 4 possible answers that could be ranked. Your task in this case is to choose the third ranking item. You need to award yourself the following points. So if your choice finishes first, then you get 1 point. If it's second, you get 2 points. If it's third, you get 4 points, because remember that is what we are looking for. And if your choice finishes fourth, you get 0. Right, this will make a bit more sense hopefully in a minute. So we have the size of material transported by the river from largest to smallest, and we're looking here at processes of transportation. So we've got suspension, saltation, solution and traction. If you think about these processes, what size bed load are they carrying with them? If we put these into order from largest to smallest, which of them would finish third? I'm just going to give you a moment to try and work that out, and then we will reveal the answer. So is it suspension, saltation, solution or traction? Right, if you need a bit more time, then please pause the video because we are about to reveal the answer. So it is suspension being awarded 4 points, saltation 2 points, traction 1, solution 0. So let's have a look at these terms. So if we start from the largest to smallest, traction are heavy rocks and boulders which are rolled along the riverbed. We then have saltation, where you've got small stones and pebbles bounced along the riverbed. Then we have suspension with very small particles of sand or clay that are suspended in the water. They can settle so the water looks clear, but generally they float along the top, and that's what makes rivers look much dirtier than they are. So they look very muddy, where actually it's just the sediment they're carrying along at the top. And then right at the bottom, we've got solution. Taking place when material is dissolved in the water, it's invisible and it doesn't colour the water. A bit tricky here because solution is also a process of erosion, so we need to remember that. Okay, we're going to work out 3 groups of phrases here. We've got a connection wall this time. So we've talked a little bit about the different processes that happen. We've talked about some of the key parts of a river basin. So we're now thinking about the long profile. We can split the long profile into the upper, middle and lower course of the river. So that's your job. On the screen we've got 3 groups of phrases. There are 12 in total. 4 of them are about the upper course of the river, 4 are about the middle course, and 4 describe features of the lower course. So have a look at them. Again, what we're going to do is going to give you a few moments, but what you will need to do is to pause the video. Remember, we are looking firstly for characteristics of the upper course. So pause the video, have a good look and note down the features that are part of the upper course. Right, we're going to reveal the upper course features. In the upper course, there is mainly vertical erosion taking place. There's a steep gradient, so the river has lots of energy. Large boulders are deposited and large boulders are rolled. Okay, so we've got 8 left. We now need to work out which of those 8 are describing the middle course of the river. So 4 of them are the middle course, 4 of them are the lower course. So which ones are for the middle? Which ones would describe the lower course? Again, pause the video now to give yourself a little bit more time and then unpause when you are ready for the reveal. Let's have a look at our middle course features. There is lots of deposition, particularly on the inside bends of meanders. It begins to erode laterally, so sideways into valley sides. Deeper channels, so greater discharge and volume of water. And the channel has a concave gradient here. And there's smaller particle size due to attrition that's taken place, which therefore means these ones here are about the lower course. So you've got lateral erosion continuing. Fine sediment is dropped, building up a floodplain. You've got a large load but with tiny particles, and you've got the greatest discharge and velocity, and the gradient here is almost flat. Right, we're going to have a go at some true or false questions now. So our first one is the velocity of the is the volume of water passing through a river at a given point. Is that true or false? Let's have a look. It is false. So that's actually describing the term discharge. Discharge increases downstream as tributaries join the main channel, and so it increases the river's volume. Is this true or false? Just going to give you a moment to think about that statement. Let's reveal. It is true. As a river flows towards a mouth, its velocity increases, meaning it has greater power to erode. Is this true or false? Let's reveal. It is true. And then finally, our last true or false is lateral erosion broadens out the river valley in the middle and lower course. Is this true or false? Let's reveal the answer. It is, of course, true. So in the upper course, you get steep sided V-shaped valleys because it is mainly vertical erosion, but in the middle course, you've got great big wide river valleys, more U-shaped, and that's because of that lateral erosion that is working outwards. Right, we're going to move on to a change analysis activity now, where we are popping together a paragraph which describes the stages in the formation of a waterfall. So on the next screen, you are going to see a number of statements that describe the stages. However, they are not in the correct order. So you need to put them in the right order to form a chain of analysis that tells us how a waterfall forms. Let's have a look. So here are our stages of formation of a waterfall. They're not in the right order. So we've got a river flows over hard rock, then soft rock. Undercutting creates an overhang of hard rock, and a plunge pool develops beneath the waterfall. The waterfall retreats upstream, leaving a gorge downstream. The overhang collapses. Attrition acts on rocks in the plunge pool, making them smaller and rounded. A waterfall begins to form as the soft rock is eroded at a faster rate by hydraulic action, abrasion, and solution. What you need to do is pause the video for a moment and try and work out what is the correct order of these. So you can just note down the numbers, and then we will reveal the correct order in a moment or two. Off you go. So if you haven't paused the video already, please do, because we are about to reveal the correct order to you. Let's have a look. So the first one was already in the right place. A river flows over hard rock and soft rock. A waterfall begins to form as the soft rock is eroded at a faster rate by hydraulic action, abrasion, and solution. Undercutting creates an overhang of hard rock, and a plunge pool develops beneath the waterfall. The overhang collapses, attrition acts on rocks in the plunge pool, making them smaller and rounded, and the waterfall retreats upstream, leaving a gorge downstream. So what we've got in this answer is plenty of key terms. We've also got a good sequence, but we've talked about specific processes of erosion, which is really important in these sort of process of landform development questions that you will get in paper 1. Right, we're going to move on to a picture grid. You're going to see 6 questions. As each question is answered, sections of an image will be revealed, and you've got to try and work out what that image is. So let's get started. Our first question is, what term is used to describe the rocks and rock fragments which are carried along by river water? So what term is used to describe rocks and rock fragments carried along by river water? Let's have a think about this one. So let's review the answer. It is load. Sometimes it's called bed load. You might have heard it as suspended load. Bed load is probably your most common. Let's have a look at what this reveals to us in terms of the picture. Okay, now as the pictures come up, our second question has also come up. How can plants help to reduce river erosion by stabilising the slope? Let's think about this one. Okay, let's have a look. So the roots bind the soil together and that provides reinforcement. Right, next question. What term is used to describe an area of deposited material on the inside of a meander? So what term is used to describe an area of deposited material on the inside of a meander? Let's reveal the answer. It is slip-off slope, also known as a point bar. Okay, name the method used of reinforcing river banks involving metal cages filled with rocks. Okay, a clue is that you also see this at the coast sometimes. So name the method used to reinforce river banks involving metal cages filled with rocks. Let's reveal the answer. It is gabion cages. Which category of river engineering makes use of gabions? Is it hard or soft? Just giving you a clue there. So which category of river engineering makes use of gabions? It is hard engineering. So remember, hard engineering is all about building structures, while soft engineering works with nature. And finally, suggest some disadvantages of using these gabion cages. So you might want to pause the video for this one if you need a bit more time. Okay, let's have a look at the answer. So they can be quite expensive to install and maintain. They can be dangerous and they are quite unsightly when they break. Right, so we have got a picture on the screen here. And what is our picture showing? Let's have a look. It is showing a river cliff or a river buff on the outside of a meander. Okay, you can see some gabions there that have sort of broken down in that picture as well. Right, we've already done one of these just a moment ago for our waterfall development. So let's have a look at the stages in the formation of an oxbow lake. So a nice geography classic here. We've got flooding subsides, but most water in the river now follows a new shorter channel. Over time, further deposition cuts off the old meander completely, creating an oxbow lake. A meander neck is eroded over many years until it becomes very narrow and then a flood occurs. Extra erosive power enables water from the main channel to break through the meander neck, and deposition occurs at the side of the new channel, reducing flow around the old meander. So 5 statements, all part of the formation of an oxbow lake, but in the completely wrong order. Give yourself a few moments by pausing the video to get these into the right order, and then we will reveal the answers in a minute. Okay, if you haven't paused already, please do so because I'm just about to reveal the correct order. Let's show the order. So we start off with a meander neck eroding over many years until it becomes very narrow and then a flood occurs. The extra erosive power enables water from the main channel to break through the meander neck. Flooding subsides, but most water in the river now follows a new shorter channel. Deposition occurs at the side of the new channel, reducing flow around the old meander, and over time further deposition cuts the old meander off completely, creating an oxbow lake. So what you will notice is missing here is stages in the formation of a meander. So students sometimes get confused here and they start talking about how a meander is formed. That's not what you are being asked for here. You are looking at the stages of just the oxbow lake itself. Right, we're going to move on to missing vowels. This time we are looking at different strategies used to manage the river. So we're thinking about hard and soft engineering strategies used to manage the river and protect it from the threat of flooding. So our first one's on the screen. The vowels have disappeared. What is this one? Okay, the first and second words should be quite easy. Maybe the last one a bit trickier. Let's reveal. We've got dams and reservoirs. So dams are big structures that break the flow of the river. The reservoir is the water that's stored behind once we're breaking the river off, so it tends to flood like a big valley. They are very controversial, so they can be incredibly expensive to build. For example, the Three Gorges Dam in China was many billions of pounds. It's one of the world's biggest engineering strategies, and it did take over a decade to construct. They are controversial as well as being expensive. They can obviously flood existing settlements. They alter the ecology of the river, all sorts of issues here. Okay, this one is Again, probably a bit trickier than it looks. So try and work out what the first word is. That should be fairly obvious. Second one, not so much. Okay, we're looking for floodgates. So when there's a risk of flooding, these are closed to obviously protect property around. Right, this one looks a bit easier because there are very few vowels in this one anyway. So we're only actually missing 3. Have you worked it out yet? It is embankment. So these are placed on either side of the river. They make the river bank itself much higher, and they increase the capacity that the river can hold before it will flood. Right, so we are now thinking less about a structure, but more about something that we can do to stop a river flooding. Have we worked this one out yet? Okay, so we can dredge a channel. So dredging basically means sort of digging out the riverbed, and obviously it's an important process in terms of keeping the riverbed clean so it's not full of debris. And if you dredge rivers regularly, it does decrease the risk of flooding. Right, last one. This is a soft engineering technique. So soft engineering is working with nature. So what do we think? Let's have a look. It is floodplain zoning. So this is really thinking about where you're building important structures. So where you have a floodplain, for example, where the risk of flooding is high, you wouldn't be building properties and businesses, but you might use it for amenity land. So for example, football pitches or for general sport. So like with coastal engineering, hard engineering for rivers is controversial because lots of people have all sorts of issues with it, lots of arguments for, lots of arguments against it. Residents living along rivers generally want it because it is going to offer them protection. So firstly, we want to think of 2 advantages of hard river engineering. Off you go. Have a think. Pause the video for a few minutes. You might want to note some things down. Okay, if you're not paused already, please do. Let's have a look at some of the things that you could have written. So recreational or tourist value. So dams create reservoirs and these can be used for a variety of water sports. So for example, up in places like the Lake District and the Peak District, you will find big reservoirs there that have huge amenity value. And the protection of property creates economic savings. So it means that people's homes are not so much at risk. The price of home insurance is going to be lower for them. They can sell their homes if they want to, all sorts. Right, let's move on to disadvantages of hard river engineering this time. So why might people be opposed to hard engineering strategies for protecting the river? Again, pause the video now. When you've noted 2 down, then unpause and we'll have a look at what you could have said. If you've not paused the video already, please do that now because I'm about to reveal the answers. Let's have a look. So it is very expensive to install and maintain, particularly great big projects like dams. Environmentally, there is lots of damage. The appearance might be unpopular. It may create problems downstream. Again, particularly dams. So they will cause all sorts of issues. You're blocking the river path. This means that the flood risk will increase upstream because you've got the idea of rivers, the water's stuck, it's not going anywhere. But downstream, it is going to cause all sorts of problems because there is less water there, which means it's going to affect potentially fishing, it might affect farming, so other people that are relying on the river. Okay, we're going to do a quick blast of MCQs. So firstly, what's the name of these features? Are they interleaving spurs, intersecting spurs? Are they interlocking spurs? Or are they intersecting spires? Let's reveal. Hopefully you spotted they are interlocking spurs. Okay, and again, they're found in lots of highland areas in the UK. Along a river, where would you be most likely to see a valley with a cross profile like this? In the middle course, the upper course, the lower course, or the diverted course? Let's reveal. They are in the upper course, so close to the source of the river. 3. What's the name given to a place where the river begins? This should be quite easy, this one. Is it source, course, cause, or source again, but check those spellings? It is, of course, the source. Number 4. In a meander, where is the river velocity usually lowest? Is it inside a bend, middle of the bend, outside of the bend, or is it the same across the whole bend? So where is the velocity usually lowest? Let's reveal the answer. It's on the inside. So the inside is shallower, so therefore there is more friction. Okay, tricky one here. What's the name used to describe this type of chart that shows the relationship between precipitation and discharge? Is it a hydro chart, a flow graph, or a hydrograph? Okay, let's reveal. It is a hydrograph. So you can see on the graph, you've got the peak rainfall highlighted there. So the rainfall totals are shown by the blue bars and the discharge is shown by the green line. The idea is that it's showing you the relationship between the two. 6. What is the missing label at 6, which in this case represents 6 hours? Is it storm time, delay time, hydro time, or the lag time? Let's reveal the answer. It is the lag time, which is the difference between the peak rainfall and the peak discharge. So the peak discharge is obviously like about when the river is at its highest level. 7. Select the correct term for cross profile Y. Is Y the upper course, the middle course, the lower course, or the diverted course? Okay, hopefully you've got this one correct. Let's have a look. It is the middle course. 8. Which two features would typically be found in cross profile Z, but not in X and Y? So wide floodplain and levees, steep slopes and a narrow channel, small floodplain and some river cliffs, or tightly interlocking spurs? Let's reveal the answer. It is the wide floodplain and the levees. 9. At the mouth of the river Ganges, which process is likely to be dominant? Is it disputation, erosion, deposition, or evasion? It is deposition. So we have a delta here that is formed by deposition. And number 10, select 2 river features you would expect to see at the mouth of the river Ganges. The interlocking spurs and rapids, waterfalls and a narrow valley, delta and braided channels, and waterfall and gorges. So this one should be quite easy because I gave you a huge clue in the last answer. Let's reveal the correct answer. It is C, delta and braided channels. Right, we are going to finish off the revision blast today with a categorised activity. You have got 60 seconds to separate the words or phrases into these 2 categories. So these are all to do with hydrograph. So we've got 2 different types of hydrographs here. We've got a flashy hydrograph with a short lag time and a high peak. And we've got a low flat hydrograph with a long lag time and a low peak. Off you go. Okay, let's see how we got on. So the flashy hydrograph with a short lag time and a high peak has a small river basin and high gradient slopes, highly urbanised with many impermeable surfaces, hence the increase in flood risk here, high drainage density and saturated soils from heavy rain that's happened over several weeks, which means our low flat hydrograph with long lag time and a low peak represents a large river basin with low gradient slopes. It's a rural landscape with forests and fields. It has a low drainage density and dry soils from several weeks of drought. Okay, well done for getting right to the end of the revision blast. We've done a number of activities in this session looking at all aspects of the river landscapes topic. Hopefully that enables you to go into paper 1 feeling a little bit more confident, and obviously we need to wish you the best of luck. So well done on today and good luck with your exams.